Okay, so you're getting ready to take a physics class, and it could be college algebra-based physics, it could be calculus-based physics, it could even be high school, I guess. But I'm really gearing this towards students in algebra-based physics at the college level. And so these courses have prerequisites, and that means that the instructor assumes that you already know some stuff. And I'm going to show you those things that you should already know. If you don't know them, that's fine. Okay, you can still succeed in the course, but knowing what you don't know, that's the important thing, and you can fix that. Okay, and usually these textbooks even have an appendix of these are the things you should know how to do, and if you need to go look at those, And this is not like, okay, we're just being mean and we're hazing people to make sure they're ready for physics. These are things that you actually need to do. If you don't know how to do them, it's going to make it really hard to do other stuff. Okay, it'd be like I want to play soccer, but I don't know how to run. Well, you kind of need to run in soccer unless you're the goalie. Even the goalie runs, I guess. Okay, so let's get started and go over some of these things that you need to know. Most of the things that you need to know. And I'm not going to go over them. I'm not going to teach you everything about them. I'm going to kind of give you an overview of the stuff that you should know. Okay, so let's start with the number one. I'm going to write these down. I'm going to write down the things I'm going to go over. 1, units. Okay, you need to know how to do that and deal with dimensions. 2, scientific notation. Now, this one is way more important in the second semester of physics because you deal with huge and tiny numbers more, but it's still important. 3, graphing. I'm not going to do a lot of graphing because I don't want to make stuff. Let's just put graphing. 4, trig. And you don't need to know everything about trig. You just need to know some things. And then finally, I'm going to put 2 equations and 2 unknowns. So how do you solve 2 equations, 2 unknowns, which is basic algebra stuff? Okay, so let's start with units. In physics, we measure stuff. And when we measure stuff, we have units with them. And the units are super important. Super important. Okay, so let's just start with a unit like velocity, the speed, the magnitude of the velocity, which we'll talk about vectors later. I probably shouldn't use that one. Okay, let's use a different one. Density. We use I should have over here 6 Greek letters. You don't have to know these. You will learn them. But we use a lot of Greek letters in physics because we think it makes us look cool. Whether it does or doesn't, no one knows. But we think it makes us look cool. So this is the Greek letter rho, and we use that for density, mass over volume. Okay, so let's say I measure the density of something and it's close to the density of water, and I get 1210 kilograms per cubic meter. Okay, so we can treat these units as though they actually are variables. And now the question is, what if I want like this in grams per cubic centimeter? How do I convert units, and how do I make sure that the units all work? Well, you see up here, the mass is in kilograms and the volume is in cubic meters, so that's how I know the units. Let me give another example. One of the things you'll see is the force due to a spring. F spring is equal to K times S, where S is the displacement of the spring, K is the spring constant, and F is the force. So in this case, I know the force has to be in newtons. I know the displacement is in meters. So then what units would K be in? Would have to be in newtons per meter, because then the meters would cancel and I'd get newtons. So the units on both sides of the equation have to work out. If they don't, it can't be an equation. You can't have, apples equals oranges, right? Because they're different things. So the units have to be the same. So how do you convert units? Let's convert this one. So I'm going to say rho is 1210 kilograms per cubic meter. Now, if I multiply this by 5 over 5, then what would happen? Well, 5 over 5 is the identity 1, so it doesn't actually change this. So I can do that, and it's still equal over here because I can multiply this side by 1. So if you multiply by 1, you don't do any damage. So what if I do this? Rho equals 1200 110 kilograms per cubic meter, and I multiply that by 1,000 grams over 1 kilogram. So 1,000 grams is a kilogram. Remember these prefix, I don't test this, okay? But we have these prefixes on the units, K for 1,000, lowercase m for 1 over 1,000. Those are the two that you see. There's other ones like micro and nano, but I wouldn't get too worried about those at this point. So, but 1,000 grams is a kilogram. So this is the quantity 1, so I'm not really changing anything. But you'll notice that now the kilograms cancel. So you have to think, I want the kilograms on the bottom, okay, to cancel that one. And then I know how many kilograms in a gram, or vice versa. It doesn't really matter. Now, be careful. A lot of people say, oh, I know kilograms, 1,000. So do I multiply by 1,000 or divide by 1,000? And you could probably figure that out. But it's better just to do it this way. What's this? That's, what did I do? Okay. So now I have kilograms per cubic meter. I actually have grams per cubic meter. And what do I do now? Well, I want to get rid of the meters. So I want that to be centimeters. So I'm going to do another one. I'm going to multiply this by centimeters. And then I need to put meters on the top. And so what's the relationship between centimeters and meters? Well, I know that if you look at a ruler, a meter stick, there's 100 centimeters in 1 meter. So if I do this, this does not cancel, right? Because I have meters, and here's meters cubed. And then I'd have centimeters. So what I need to do this would be meters squared centimeters. Only one of the meters would cancel. So I actually need to do this 3 times. So I need to cube this whole thing. So if I do that, let's write this out. I get 1210 times 1,000. And then I'm going to have, this is going to be grams per centimeter cubed. Because, right, the centimeter cubes is going to be down there. The meters cubed is going to cancel. But now I have 100 times 100 is, I'm going to get 6 zeros here, right? So this is going to be over 1, 2, 3, 4, 5, 6. Okay, now you think, oh, I got to put that in my calculator. Well, yeah, you can. Okay, but you don't have to, because I can start canceling zeros. Here's another 0. Actually, that's 1,000, right? And now I just have 121 divided by 100, and I can do that. That's 1.21 grams per centimeter cubed. Okay, you're going to need to practice that, and I'm not going to have a giant lecture on units. The important thing is that both sides have to have the same units, okay? And units are important. Scientific notation. Okay, the mass of the Earth, I can't remember the actual number. The mass of the Earth is it 6.24 times 10 to the 24th kilograms. So this means, let's use a different one. Let's use the radius of the Earth. Actually, this is, I can't remember. I'm going to Google it. It's okay to forget stuff. Let's see. Mass. Let's see, radius of Earth. In meters. It's 6.37. So this is 6.371 times 10 to the 6th meters. I can write that out. Okay. I got the mass of Earth in kilograms. I don't want to be wrong. It's 5.972. I was close. 5.972 times 10 to the 24th kilograms. Okay, so let's write this number out. This is actually, the radius of the Earth is 6371000 meters. And this would be really bad to write out, right? Because it's a really huge number. But what this means is it says, okay, what if I factor this out? I can factor out 10, let's say 1 million. Okay, so if I want to factor out 1 million, I could say this. a million, 100,000, that's 6, divided by 100,000,000, 10 to the 6th. Yeah. So I didn't change anything. Now I'm going to leave that one there. This one I divide. If I divide by 10 to the 6th, I need to move the decimal place 6 places that way. So I get RE equals 1, 2, 3, 4, 5, 6. So I get 6.371 meters. But then I still have this other one, 1, 1, 0, 0, 1, 2, 3, like that. So if you multiply these together, you get back to the original number, and that's good. Okay. And then I can write this as just 10 to the 6th, right? So there's 1, 2, 3, 4, 5, 6. So it's 10 to the 6th power. So I can write this as equal to 6.371 times 10 to the 6th meters. And that's it. That's scientific notation. This is a way to write really big numbers or really small numbers. Another one that we're going to see is G equals 6.67 times 10 to the negative 11th newtons meters squared per kilogram squared. This is the universal gravitational constant. It's super tiny. Okay, so I don't want to write out 0.0 and then a decimal point, then 10 zeros, and then 667. That's just no fun. Okay. Now, when you enter this into your calculator, let's go over this, because this is something that you need to practice. Okay, so here I have a calculator. Can you see that? Oh, that's better right there. Let's turn it on, and let's clear it. So let's enter this in scientific notation. So I'm going to say 6.371, and then there is a scientific notation button. I'm not a big calculator person. Don't do this 10 to the x. Where's my... let's see. EE right there. So then put second EE6, enter. Okay, and it converted it into as a full number if it could. Okay, let's multiply this by the gravitational constant just to see what happens. Okay, so I'm going to clear that out. So let's enter in this 6.67 times 10 to the negative 11. So I'm going to enter 11 and then change. Oops. 6.67 scientific notation, negative 11. Don't use minus. Don't use the subtraction sign. Use negative. Enter. Let's just say times 6.371 10 to the 6th. Enter. Okay, now in this case, it gave me a number not in scientific notation. There's probably a way to convert that, or you can just say, okay, 1, 2, 3, 4. So the answer would be 4.24 times 10 to the negative 4th, because I moved the decimal place 4 places to get to that. I don't know what, this is a good time to talk about calculators. I like this calculator because it was like $11, and I actually found it, and I didn't even pay $11 for it. I don't mean to be a negative person, but if you have like a TI-86, that's cool, but don't go spending $110 on a TI-86 when this does essentially everything that you need. Okay. For my classes, if you want to use something else, that's fine. I mean, I don't have a calculator requirement. What you do need on your calculator, you need scientific notation and you need trig functions and square roots and stuff like that. So if it's a super, super basic calculator, it's not going to work. This one is fine. Okay. But whatever you use, find a calculator and know how to use it. Know how to use scientific notation. Now, here's another problem that I see people have. They'll say clear. How do you enter 10 to the 6th? Oh, they'll say, it's scientific notation. So I'll say 10 scientific notation E6. That's wrong. That's actually 10 to the 7th, right? That's 10 times 10 to the 6th, which is 10 to the 7th. Okay, so be careful about that. Okay, scientific notation. Okay, graphing. I don't want to have I have a graphing tutorial, but let's say I have this. Let's say this is x as a function of time. We'll definitely deal with that. Like that. Okay, so this is just a sketch. It's not an actual graph. But what this is a collection of data points. So this point right here has some particular x value and some particular y value. And that's important, right? And we can see that over time, a little bit later, it has a different time and a different x. And so this is a way to represent a whole bunch of data. It's a way to represent data. One of the things that we're going to do also is find the slopes of graphs. In this case, it doesn't have a single slope. But we can still imagine the slope at a particular point as just a tangent line to that. So it's like this. And right here, it would be like this. Okay, and so the slope of this line would be the change in x over the change in t, and that actually means something. I'm not really sure what to say about graphs, except that the one common thing that students come in with ideas about graph is that a graph is a picture. Okay, it's not a picture, it's data. So you got to think about it in a different way. And so we could plot anything. And we don't have to have time on the horizontal. We don't have to have x on the vertical. It's not x versus y all the time either. That would be a trajectory. So if you think about it as just data points represented as a line, that could help. I don't know what else to say about that right now, so I'll just move on because this video, I don't want it to be 80 minutes long. 30 minutes would be okay, but 80 is a little long. Okay, trig. If I say trig and you think of this, like a sine curve, this would be like, let's say, a y is a function of theta or something. I don't know. That's fine, okay? But it's more than that. That's just something that comes out. And it's not even about circles. It's about triangles. Trig is all about triangles, and you will use these triangles a lot in this class. So if I have a right triangle, in particular, a right triangle, like this. And so this is some angle theta. I'm going to call the opposite side y and the horizontal side x, just in this case, okay? Because we normally draw it like that, x and y. So it turns out that if you have a right triangle, there is a relationship between these three variables for all right triangles. So if I take let's call this r. So let's first think about the Pythagorean theorem. The Pythagorean theorem says that the relationship between these three sides has to be the following. R squared equals x squared plus y squared. That's the Pythagorean theorem. And then a lot of times we'll say r equals the square root of x squared plus y squared. You'll see that too. But that's just the Pythagorean theorem. Now, the other thing that we find is that there is a ratio. If you take the opposite side to this angle, if I say y, and I divide by r, the hypotenuse, and then it doesn't matter how big of a triangle it is, they all have the same ratio for the same angle theta. It doesn't really matter. That ratio is the same. Okay, and that ratio is some number that we could look up. But we call that lookup function sine. So sine of theta is a function that says if you have this angle, that's the relationship between y and r. That's what sine is. Now, what's the greatest y could be? If r is equal to 1, the greatest y could be is 1. Right? So the greatest this can be is 1. The lowest it can be would be -1. I could have y as -1 down here. Okay. So this sine of theta is between -1 and 1, and it has no units because it's a ratio of sides. If I look at the adjacent side divided by the hypotenuse, that is cosine. Now, if you're doing this in real life, if you're doing this on a calculator, you got to realize that your calculator could be in radians or degrees mode, so your angle has to be corresponding to your calculator too. So don't make that mistake. But these are the ones that we use a lot. Every once in a while, we also say if I take y divided by x, that's tangent of theta. I just want to show you something real quick. This is a standard math tables book. And this was mine from when I was in school, in college. Trig functions. Yep. So this is a lookup table. It's a lookup table for the different functions. So this says that if I have an angle of let's pick down here, 0.2618, then the cosine of that is 0.9659. It's the ratio of all these different sides that we could think of for different right triangles. Okay, that's what the sine does. It just looks up these tables. Essentially, it really does that. Even when your calculator does it, it's mostly just either looking up a table or making an approximation to those values. Okay, but this is what you need to know in trig, because this is the basis for vectors, and we're going to use vectors a lot. You don't need to know what vectors are at this point, but that is super important. Okay, last thing that you should know coming into your physics class, and that's solving two equations to unknowns. There's other stuff that you should probably know, but these are the big things. So I'm gonna write two equations, and these are legitimate, real equations that you're gonna see in physics. This is an actual physics problem. Okay, there's one more thing in here. Let's actually write this as let's just write this as this one. This is a simpler version. Okay, so this is x0 plus vx times t. This one is y0 minus 1/2 gt squared. Okay, so suppose that I don't know x or t. How could I solve this system for both of these variables? So the thing that I would encourage you to not do, that they teach you in math, is to say, okay, well, I need to add these two equations together to get things to cancel. Sometimes that works, but sometimes it doesn't. So in this case, it wouldn't work because I have t and t squared. Okay, but what I do want to do is just solve one of these for a variable and then plug it into the other equation. So in this case, if I want to find x and I don't know t, I have to use this to solve for t. So let's just solve this for t. Let's say I'm going to subtract y0 from both sides, so get y minus y0 equals negative 1/2 gt squared. And g and 1/2, all these are numbers except for t. Now I'm going to divide both sides by negative 1/2 g, so I get y minus y0 negative, and there's a 2 over g equals t squared. Now, maybe we don't want to take the square root of negative numbers, so let's just move this negative sign in. It's not a negative number. And then I take the square root, and I get t equals the square root 2 y0 minus y over g. Now I can plug this value in for that. So this gives me x equals x0 plus vx, and instead of t, I'm going to write this whole thing. The square root of 2 y0 minus y over g. And then we're done, right? Because I know all these other values. But that's how you're going to solve two equations to unknowns. You're going to take one of the equations, solve for a variable, and then plug it into the other equation. And this is just one example. We see this all the time. Now, there is one other thing that I would like to point out that does come up. What if this equation was this? Y equals y0 plus vy, that's a y, t, minus 1/2 gt squared. And I want to solve for t. Everything's a variable except for t. How would you find that? Well, you can't. Okay, you can't get it easily. So instead, we're going to have to use a quadratic equation. So I'm going to write this as 0 equals y0 minus y, I subtract y from both sides, plus vy t minus 1/2 gt squared. So now I have a constant plus b times t plus c times t squared. Is that right? No, it's the other way. No, that's a. So it's, I just blanked out for a second there. So I'm going to say this is a t squared plus bt plus c. So A is equal to this term, negative 1/2 g, B is Vy, and C is this term. Then I can find the solutions. T is going to be negative B plus or minus the square root of B squared. Wait, the plus or minus is in here. Negative B plus B squared minus 4AC. No, it is plus or minus over 2A. Why did I just forget this? You sometimes just blank out, right? I'm looking it up because I forgot. And I don't expect you to remember it. I know you should know how to use it, though. Yeah, I got it right. Okay. I just doubted myself. So in this case, I would have these numbers and plug them in. Okay. So that's enough to get started. Like I said, if there are any of these topics that you don't feel comfortable with, that's fine. You can still do well. Just make sure you know what you do or do not know, and look at the appendix, ask questions, be prepared. But if you go in thinking I can just go through and not know those things, that's when you're going to have a problem. Okay. Hope that helps.